everyone can hear me, and hopefully you can all see my slide and not my notes. And hopefully the slides will change over okay. So thank you very much for that introduction, Nicolo. As said, I'm talking about a new research project. So thank you very much for coming along to listen to what's a bit of a drafty and preliminary sort of paper, but it's sort of what I've got so far for a relatively new project, a fellowship funded by Newcastle University. While at Newcastle, however, I'm also connected to the Water Security and Sustainable Development Hub, which is a sort of interdisciplinary entity at Newcastle. So for the fellowship in particular, I'm exploring the long-term development of water management in the context of the sort of water security and future sustainability. And it's developed out of a number of projects. So my PhD at Durham explored and revealed a sort of complex landscape of water management irrigation in northern Mesopotamia, particularly using 1960s declassified Cold War spy satellite images. But in particular, this showed significant investment in irrigation in the medieval period, which had perhaps sometimes been a bit dismissed as a time of just sort of reuse of our old irrigation systems. I later worked for the Endangered Archaeology Project, and it became increasingly clear to me while working for Amina that the remains of ancient water management features are some of the most at-risk kinds of archaeology. They're often in the best locations for agriculture, for water management, so they tend to get removed to make way for new irrigation schemes, which often in themselves involve things like unsustainable diesel pumping. So I'm quite interested to know how past irrigators dealt with challenges such as environmental and climate change, the impact of political changes and so on. Perhaps if we can understand this, it'll give us a bit of a long-term perspective on what worked and what didn't, which could be valuable for future policies of water management. Indeed, the IPCC, the Intergovernmental Panel on Climate Change, has called for a better understanding of what it terms traditional water management practices. So this is in the context of the threat to food security posed by climate change, which is significant in the Near East and North Africa. A reduction in precipitation is likely. This will amplify existing stress on water availability. There's a lot of pressure on water resources at the moment. So I think, for example, by the 2050s, the Oasis of southern Tunisia are expected to experience something like a 29% decrease in precipitation. Overall, a rise in temperature could have negative impacts on crop choices, for example, even on date palms, which are pretty heat tolerant, and on things, especially on things like fruit trees. The IPCC emphasised the importance of local, traditional, indigenous knowledge systems for sustainable resource management, but this knowledge is really at risk of being lost. So the need for a longer term view is raised in this context. Now, given the challenges of climate change amidst the loss of these water management systems, these traditional systems, investigating them is now quite urgent. But they can be contextualised perhaps nowadays in the framework of the Sustainable Development Goals, or SDGs. The SDGs represent an agreement by the member states of the UN General Assembly to address sustainability through 17 goals. And some of these in particular are relevant to this research project. So particularly goal 6 around water. So this is one of the most relevant ones. It's just focused on sustainable water management, and we can look at past water management in this context, exploring to what extent it might have been sustainable or not, trying to understand what caused it to fail at times, and how that could be avoided in the future. Also trying to understand case studies where there was a lot of longevity, that irrigation systems lasted a long time and were resilient to changes. And this sort of brings us into goal 13, which deals with climate change and resilience and things like natural hazards, drought and flooding, and how that can impact on water management. But also goal 15, this encompasses the issues of desertification, land degradation, which is really relevant in North Africa and the Near East. So to really understand to what extent the land is actually desertified, we need to understand whether the extent of cultivated areas has changed in the long term. There tends to be a bit of a disconnect between sort of archaeological and historical studies of sort of oasis or past water management landscapes. They're sort of a snapshot in time with a lot of detail, whereas you get your sort of geography, engineering studies, which are another snapshot based on very recent events, and they sort of joining these two things together can give us this much longer term perspective to understand was there a greater extent of oasis in the past? Has the oasis actually shrunk, or has it just moved or increased? And how sustainable any kind of increases might actually be given the threat of climate change. So I'll show some examples of former irrigated areas which are since desertified. These historical and archaeological landscapes rarely seem to be incorporated into modern discussions around climate change, or not often enough. So it's all very well to talk about archaeology in the context of the SDGs and sustainability in general, but it's much harder to find ways to really implement any of this data for addressing the SDGs. So the FAO's initiative, the globally important agricultural heritage systems, and this is also quite a nice framework for this. So this framework, it recognises that many great rural landscapes have evolved from the co-adaptation of a community with its environment. It aims to identify and safeguard globally important agricultural heritage systems, establishing a long-term programme to support these environments. So this can involve leveraging global recognition, coming up with policies or influencing policies, promoting agrotourism and establishing designated sites, similar to, for example, World Heritage designation. So there's a set of criteria that have been established for designation. So I won't go through them all, but these include things like the presence of sort of local and traditional knowledge, and that includes knowledge about water management, even things like sense of place, but an integration of food production, the environment, culture. But it also includes things like a slow evolution of that landscape with a long historical persistence. So I think for many past water management landscapes that is quite relevant. Some of them do seem to have persisted for quite a long time. So there are a few of these designated globally important agricultural heritage system sites in the MENA region. So one example I can mention here is the Gafsa Oasis in Tunisia, which was designated because of a water management system that's been well preserved using local knowledge, and it has, you know, that multi-layered agricultural system, which I'm sure many of you are familiar with, where you have your palms and your fruit trees, your cereals and vegetables, but it's now threatened by sort of modern development and an increase in private property. There are a few more of these designated sites. I don't have time to talk about them all today. So I'll talk about a few case studies from my research and outside my own research in the MENA region, and these include quite a few collaborations, which I'll say more about in a bit. But I'm working in this area. Apart from some parts of the region, there's not much possibility for rainfed cultivation, so irrigation is necessary. And I always say this, and have to sort of remind myself, so I think it's easy to forget sometimes, the biggest user of water is always going to be irrigation. It's not domestic use, even industrial use. Irrigation is the biggest user of water. So we're thinking about irrigation in terms of agriculture and cultivation. So precipitation is becoming more reduced and variable. Much of this area is very arid, and pressures on resources are very significant, and it's leading to further water scarcity. However, unsustainable modern technology to extract water, diesel pumps and so on, this leads to degradation of the groundwater, salinisation and so on, and this just sort of exacerbates the problem. So in terms of my sort of methodology for this work, I'm using a range of data sets. So initially and primarily remote sensing, so a lot of it uses satellite imagery, so some high resolution imagery, such as example here, we can really see the layout of individual sites and digitize them. A lot of this, of course, is available for free on Google Earth. Others can be purchased and obtained. Also using historical satellite imagery and aerial photos where possible, such as this corona image here. Although it's old and doesn't have some of the amazing properties of the modern imagery, it really allows us to see the landscape back to the sort of 60s and 70s, or even earlier for some of the aerial photography, before modern changes have sort of removed traces of former irrigation systems. So I think this little example here is a canal alongside the Euphrates in Syria, which has since been removed by the Tapka Dam. I'm also, of course, using elevation models. These are useful for modelling the hydrological properties of irrigation systems and the environments they're in. Using multispectral imagery to automate detection of changes that affect these areas, these landscapes. And also fieldwork data where possible. I'm collaborating with archaeologists doing fieldwork in the region. I'll say a bit more about some of this in a bit. And hopefully I'll be able to do some field work when it becomes possible, if the pandemic eventually ends. So to record features, I'm just using a sort of bog standard simple image interpretation methodology. So taking into account sort of space-borne and ground evidence. So for example, in this key here, we might have space-borne view, a satellite image view of the Foggara, so our underground tunnel collecting groundwater. It's quite a distinctive feature with these maintenance shafts above the tunnel, and we know what it looks like on the ground as well. So trying to sort of be a bit standardised in approach to digitising these features. And mostly the kind of features I'm digitising, there's a lot of Foggaras or Kanats, these underground features. So these have got many, many different names depending on where they are, which could be a whole sort of interesting topic to get into, but I have to try not to go into the sort of Fogra or Canat tangent, even though they're very interesting to me. But they, from the diagram here, you can see they're collecting groundwater, areas where it's available, and transporting it to the fields for cultivation. I'm also mapping a lot of sort of open channel, reticulated channel systems with a sort of gravity flow systems. Sometimes you can get multiple parts of the system, the main channel and the laterals and so on. Even sort of elements of drainage are sometimes identifiable. And of course, there are smaller things like wells, systems and things like that, which sometimes we can see from satellite imagery or recorded through fieldwork as well. So firstly, for sort of case studies, I'll talk very briefly about my research in northern Mesopotamia. This comes from my PhD work. So apologies if some of you have seen this before. In much of this area, rain-fed agriculture is possible, but conditions are very variable and uncertain. So you can maybe see this green area here on the map. You've got your 200mm rainfall ice height and your 300mm ice height. Sometimes, especially as archaeologists, we tend to sort of fall into a trap of sort of seeing those lines and think, well, I'm standing on one side of that line just south of Raqqa and it's definitely not raining, and then I'm standing on the other side of it and it's definitely raining enough to cultivate crops without irrigation. But of course, it's not quite like that. This, you know, especially where rainfall is quite low at these margins of sort of enough rainfall for cultivation, conditions are very variable and uncertain. So if you want to ensure good yields for your crops, you do need to irrigate. And as you can see from this map, this area, even above this 200mm line, was filled in with a number of irrigation systems from the Bronze Age through to the medieval period. So not just relying on that rainfall, but also irrigating. So you can see you've got Euphrates and Tigris of lots of systems of various periods here. But also, like for example, the Balik, very intensely cultivated, but also away from the main river systems. For example, here around Membij and here around Sinjar, you've got lots of Kanat systems making use of areas of enhanced groundwater. So I think in some way this shows that the kind of intensive cultivation that we sort of irrigated cultivation that we have nowadays in the region, it's not totally unprecedented. You do have extensive use of all these water resources in the past as well. And even where you have that possibility for rain-fed cultivation. So you see these very sort of dense network of channels around the Balik. So I can sort of zoom in on this now. So this is a nice example of very dense irrigation, especially in the medieval, the early Islamic period. So the whole valley north of Raqqa is full of irrigation systems, and quite a few of these do date to this, even originate in the early Islamic period, and others seem to have been active in this period. I did a bit of fieldwork here in 2010, but Tony Wilkerson did much more intensive fieldwork there in the 90s. I was able to record some of these features. You can see that many of these features are visible on the corona imagery. So there's an intense sort of agricultural area supporting the town of Raqqa, which is of course a key town for the Abbasids for a while. But Raqqa itself, or the different parts of Raqqa, sort of industrial areas, palaces and so on, had separate water supplies as well, so canats, but also this open channel system that becomes a tunnel to traverse this area of higher ground. And you can see its profile here. Easy to mistake it for a canat. You can see it here as an open channel in the corona imagery, little structure there. Becomes a canat down here, more little structures, and then it kind of opens out into this area, this early Islamic palace just north of Raqqa. But of course, as I've said before, and I'll try not to say too many more times, irrigation is the biggest user of water. So all the sort of cultivation going on in the Balik, perhaps spurred on a bit by the presence of Abbasid Raqqa, this cultivation is requiring a lot of irrigation, and including some quite sophisticated systems. For example, the narrow Abra system in the north, very nicely visible on the corona images. Unfortunately, when we visited in 2010, it had pretty much been removed. There was a line of wells, though, along its course that we did see. Now, this is a really, really flat landscape, the Balik. I mean, before I went to Syria in 2010, I'd not been to many places. So I sort of looked at this place, it's very flat and completely cultivated landscape, and sort of thought, wow, this really looks like my own landscape where I'm from. It looks like the East Anglian Fenlands, kind of around Ely or something. Just a bit hotter. So this system is actually quite clever, because it's in a flat landscape like this, it can be a bit difficult to get enough elevation for your canals through gravity flow, but it's flowing along a very slight ridge of high ground you can see in the elevation model here. which means that the laterals coming off it, they have just a little bit more elevation for irrigation to irrigate the different fields. But we can sort of try and contextualize this in a modern situation in Syria. So you see the three Landsat composites here, and this shows the red areas of this false colour image shows where modern cultivation is taking place, with the past, the ancient systems overlaid in black. So you can see that all of these ancient systems are now impacted by these areas of modern cultivation and are really disappearing. In fact, the corona imagery, the historical satellite imagery, previous surveys are really now the best way to investigate these systems. But you can see how you've got these large-scale systems developing. It's getting redder, therefore greener, since the 80s, or drawing on dams and things on the Euphrates. But it has been a bit disrupted by the more recent conflict, with some of that greenness decreasing again, affected by that conflict. So, of course, I need to talk about southern Mesopotamia. It's a very important area in general for the history of water management. And I really don't have time to talk about it all in detail. Again, I could get lost on the tangent of that. Now, the history of research in water management in the Near East, it's often been caught up in these narratives of power and control. I will say the word whipfogle, but I won't say much more about it. You'll probably be pleased to know. Whereas the concept of sustainability is a much sort of newer framework, which is starting to be applied by this data. Some scholars in the working on archaeology in the area starting to look at these landscapes, and especially water management, through this sort of lens of resilience and sustainability. So I'll talk a bit about a little case study, which I've been working on with Dr Jaafar Jotheri, Dr Lamin Abdulaati, and Dr Michelle de Grucci. This is funded by BISI. So this is sort of focused around the area of Irrigated, because it's now desertified, but it's an area of former irrigation, which should show evidence of some of the earliest irrigation, the earliest cultivation. So hopefully you can see these features, these crevasse splays here. So these crevasse splays, so the gradient of the plain in southern Iraq, it's very, very low and flat, but the Euphrates is flowing a metre or two above the plain on the crest of natural levees, which are made up of the deposited sediments. So this allows extraction of water just down that levee slope, just a break in the levee, and then you've got your water to get a slightly steeper gradient for your irrigation. This could even be natural or could be man-made. And it's a process which could be modified and extended over time by local communities. So you get this sort of pattern of this crevasse splay, quite visible on the satellite imagery here, sort of spreading out. And water taken off levees in this way, either naturally or deliberately created this crevasse splay. And we think this is some of the sort of earliest forms of irrigation. In some parts of the region, that sort of developed into a herringbone pattern of channels. And these early stages of irrigation technology were eventually sort of modified and ending up as a sort of regular system of channels with fields of similar size and sort of farms around in between. So for our Irrigated project, hopefully you can see from the data digitized from the satellite imagery that we've got a relic course of the Euphrates here highlighted in green. The Euphrates is now across to the north. So it's now blocked by this sort of sand ridge here to the north. So archaeological evidence from this area in general suggests that this course of the Euphrates was active in the second millennium BC, and at some point the course of the river moved. And we know from historical texts, for example, from the Babylonian period, that the state sponsored engineering works to try and restore water to cities such as Eridu, doing dredging and things, but ultimately it wasn't that successful. There's quite a few crevasse splays here. Maybe you can see from the mapping, it's a bit of a tangle of channels, but you can see one going here, one coming off here, and one here. Because it's quite a complex tangle of channels, there's probably channels of different periods sort of overlying each other. Following the mapping from the satellite imagery, fieldwork was done in October 2020 by Jaafar and Rahim. The pink dots show locations of interest to visit in the field for survey, such as significant channels and channel conjunctions. And you can see this nice flat landscape here. So these canals are actually quite visible often on the ground because of the sort of presence of moisture and some vegetation. So you can see this one marked out here in red, and this one doesn't even need marking out. It's quite visible. And these are photos from Jaafar from the fieldwork in October. And when we tried untangling these channels, sorting them out a bit, Michelle sorted them by angle of degree, and you show that does start to reveal some interesting things. So this particular long crevasse splay channel here shows up quite nicely. This sort of quite fat one here, another one here, and lots of bits and pieces of channel in between, including some sort of more modern canals here and some linear features here. So we excavated, or Jaafar and Rahim excavated trenches across five channel profiles, photographed and recorded them using GPS. You can see recording in progress here. And they gathered shells from the channel fills, sent them back to me. Newcastle Airport kindly opened them and didn't really pack them up again very well, but luckily enough survived that they're now being processed for radiocarbon dating. Unfortunately, I don't quite have the results on that yet, but it'd be interesting to see what we get from it. Because I think this case study does give us an insight into some of the earliest stages of irrigation. And these environments could have lasted quite a long time, forming potentially quite sustainable sort of environmental niches, even though they're sort of now long desertified. So I'll move on to North Africa now, which is sort of the main meat of my current fellowship. Now, for my NUAT fellowship, I'm trying to look at oases across as long a period as possible, including a present day, trying to bridge that gap between archaeological, historical, and sort of modern geographical and engineering studies. So oasis agriculture in North Africa probably originated prior to the medieval period, but started from Egypt and sort of extending out, going back into the first millennium BC. But I think many of the layout of many of the oases probably originated at least in the medieval period or a bit later. But in many of those places, it's still surviving today along the same sort of lines. And this longevity might suggest particular sustainability inherent to these environments. So it's something we need to look into. And if you're interested in the early oasis agriculture of the Sahara, do see a new volume by David Matterney and Martin Sterry, published by Cambridge University Press. We have a paper on the Jufra oasis in that volume. So thinking about the impact of climate change and the pressures of water resources, these oases are now very vulnerable to these problems, but we still perhaps don't know enough about how they were traditionally managed. And there's a risk that the systems will degrade or be destroyed just beyond viability before we can record them and understand their potential to inform future sustainability. So I'll try and identify criteria that may have made them water secure or not water secure, by looking at the sort of natural conditions they adapted to, environmental challenges, political changes they dealt with, so sort of how humans dealt with that, and what the sort of water management in terms of the technology and the social strategies were that facilitated this, in terms of how do we get from this nice environment up here down to this sort of bulldozed environment down here. These are not the same place, by the way. So the first case study I'll talk about from North Africa is Jufra Oases in Libya, where I'm working with Dr Muftah AlHaddad and Dr Lamin Abdulaati, and that's for an SLS-funded project. So in the arid Sahara, irrigation is of course needed for cultivation, but groundwater is the main source of water. So there's lots of archaeological sites in the areas taking advantage of that. In Jufra, we have sort of 3 central towns, Sukna, Hun and Mudan. I'll maybe talk about Hun and Mudan today, but each has its area of irrigated oasis around it with palms and cereals. Muftah did fieldwork in 2013, recorded quite a few of these settlements. We can see many of them are medieval in date, with several different phases of these sites, of oases with sort of different settlements moving around. Some Roman pottery was observed as well. So it seems very possible that the oasis originated in pre-Islamic times, but I think there are several different phases of foggera use here, and I'll come on to that in a minute. So there does seem to be a sort of sequence of different nucleated settlements and areas of water abstraction, perhaps active and then becoming inactive and abandoned at different times for these several groups of foggerers. There's lots of other sites, cairn cemeteries and so on as well, lots of good archaeology here. But hopefully, as this video shows, you can see the sort of rate of intensification here due to modern sort of pumping and so on. You can see the oasis really expanding, and this is really threatening the survival of archaeological sites in the area. So as part of the Amina project, I was working with automating sort of detection of changes that affect archaeological sites, all types of changes, urban and so on, as well as agricultural. And I'll show how some of the results of this feed into the current project. So for that work, we're really keen to rely on open source satellite imagery and software so that it can be widely accessible. I'm quite critical of projects that just use expensive imagery, which has restricted licenses. It makes it impossible to sort of replicate that work and really sort of get any useful result from it, I think. So in this case, we use Sentinel-2 satellite imagery to detect changes in the vicinity of archaeological sites. It's free and open source. even though the resolution isn't amazingly high, it revisits every location every few days, so we can start to see changes. It also collects information in a number of bands from the electromagnetic spectrum, so we can understand the different properties of different materials on the Earth's surface, and thereby automate detection of those changes of the types of features that are on the surface. Using some other imagery as well where we can, for example, PlanetScope imagery. It's slightly less open access, so some availability open access. That is tiny little baby satellites here. I think they're sort of calling them doves now. And these are useful because they visit every day. So these are quite good if you want to pinpoint exactly when a change happened. So we use the free tool Google Earth Engine to do this, setting up some bespoke code so it can be easily rerun. And you can find the code and the sort of details of the methods in our recent paper, and Jotheri is one of the 2 case studies in this paper. So this code allows the user to define a place and date ranges that they want to compare, and then it uses a per pixel algorithm to compute change magnitude. And then this information is appended to a list of sites, so you can automatically get a report of which sites there may have been changed. And it's a fairly sort of blunt methodology. It doesn't bother to try and tell you what the change is. It's just telling you there has been change. And this work is still being worked on by Amina, still collaborating with Amina, but in particular, Dr. Nicole Sheldrick at Leicester University is doing cool things with this now. So just an example of it, you can see Foggara here in Jotheri starting to be destroyed by new tree planting holes. And this has been picked up and highlighted in grey by the change image here. So we can start to detect these changes perhaps before the feature is entirely gone, and try and do a bit of recording before it's too late. So the biggest cause of damage to archaeology in this area is these sort of new field systems. So we can see that the Oasis in Jotheri, of around 90 sites we've recorded in the area, 47 have been destroyed or damaged in recent years by this modern agricultural activity. And again, the remains of water management are particularly affected because they happen to be in the way where people want and need to build new irrigation schemes. And we can see that the size of the Oasis increased significantly. We did validate this work. So overall, it's actually pretty accurate. So we do have a good user's accuracy in that because we didn't get any false positives in this case study. We did get some in other case studies, so it's kind of just luck that we didn't get any here in Jotheri. And a few instances we missed, the algorithm missed some instances of change. Sometimes they were a bit small to show up with the Sentinel-2, the 10-meter pixel size. But overall reasonably accurate. And you can see the red triangles are the ones we missed, and the purple are the ones we actually did detect correctly. So just an example of that in action. We've got a nice Foggara here, south of Verdun. And here it is being almost totally destroyed by these new field systems. And you can see it's one of the 15 correctly identified instances of change, but it has quite underestimated the size of that area of change. Although I will say it's taking a sort of a median composite from a set period of change. So it's often things like new fields which are damaging Foggaras. So just a bit of a close-up of those Foggaras south of Verdun. We have really nice relict Foggaras here. I've got these highlighted in blue, and in green we have things like little associated settlements and field walls and so on, just on the edge of this ridge here. So these are flowing from the south to the north. But as you can see, they're being subsumed by these modern fields. So these perhaps date to something like the early 1st millennium, maybe. Some Roman ceramics were found here. And one of the aims of our SLS-funded project is to investigate these in more detail and try and find some more material for dating, and also more survey before they're completely destroyed. And here's a close-up of one of the Foggaras, quite nice there in the worldview imagery. So a bit before they started getting destroyed. And here you can see some of the little field walls and so on, even like a little basin, perhaps a little reservoir here. So another area of Foggaras I'm interested in Jotheri is to the south of Hun. Now these are much more badly destroyed already than the ones in Verdun, by and large, but we can see these in a 1972 corona image, not a very good quality corona image, but good enough that we can see the lines of the Foggaras, and mostly destroyed by the time of the modern imagery with a few little associated settlements and things. And we'll also investigate these ones as part of the SLS project. So we're thinking that these might be a slightly later phase of Foggara activity, because Dr. Lamin Abdulaati has already been investigating some of these. I think he has some anecdotal evidence from people in the area that some people may remember some of them flowing. So he started to excavate and survey some of them. You can see one here. And here's some nice photos from Lamin and his colleague. You see they're much braver than me, and they've gone into the scary Foghorah tunnel. There's actually water in it in here. Sometimes if there's a runoff, there'll be a bit of water in the Foghorahs. You see here, this one, they excavated this shaft and found like bits of palm fronds and stuff in the bottom. So Lamin suggesting that the tops of the Foghorah shaft could have been capped or covered by these palm fronds, which is a nice finding. So to sort of sum up this particular case study, we can see that these remains are particularly at risk because they lie in these areas where groundwater can be exploited nowadays with diesel pumps. So you can see how the cultivated area has gradually increased, especially since the conflict in 2011. And you can compare the 1980s Landsat composite with the more recent one and see how the Oasis area has really increased and how it's starting to threaten these these foggers, which are formerly sort of out quite a long way from the modern Oasis. We've extracted this information from satellite imagery, Landsat imagery, which goes back into the 70s and 80s. So given that these Foghorahs are sort of clearly long abandoned, this suggests that at some point they became unsustainable in the past, perhaps by over-abstraction, excessive abstraction. So I think this is quite a nice example because it shows that we can't just take an overly simplistic view of past or traditional water management, meaning sustainable water management. We're not saying sort of old means good. In fact, the same thing is happening in Jufra today and in many other areas as well. The same sort of trajectory of unsustainable water management. So on to my sort of last set of case studies. These are from southern Morocco, a few from my own research and research collaborations I'm doing. And I'm broadly looking at this area sort of south of the Atlas Mountains into the Sahara. So in particular, I'm collaborating with the Middle Dra project. I'm sure the directors of MDP need no introduction to people here, and I'll talk about MDP a bit later on, and also some locations outside the Dra. But there's loads of important oases in this area. I don't have time to talk about many at all today. Really, I can just give you a few snapshots of them. Sort of one point I wanted to make by looking at this time series. So this is from the Landsat imagery from the 80s, so starting with Landsat 5 up until today, going into Landsat 8. And it's looking at, there's a sort of size of the vegetated area across the years. And you can see sort of normal cyclical changes. But I think you can also see some events outside that. So the lower values are sort of water and snow and things, but some of the higher values are times of flooding, which isn't necessarily a good thing, even though it means lots of water, because it can cause damage to irrigation infrastructure. In particular, this flood in winter 2014, autumn 2014, and I'll be showing a few examples of the damage that particular flood caused later on, because these oasis systems are very vulnerable to flooding, but of course to drought as well, desertification. But flooding in itself can lead to that desertification, and we should consider how this is dealt with in the past as well as today. So just a little case study from outside my own research really is fig rig, so we can look at this to try and understand what some of the threats to sustainability might be. I'm discussing this one because it's actually a contender for designation. It's a nice example of southern Morocco. Water is quite scarce here, has a nice traditional oasis with fortified villages, which probably originate in the medieval period and later, Foghorah irrigation as well, of course early irrigation. There's various modern policies now active in the area, which are particularly focused around things like making careful use of wastewater, trying to be particularly efficient about water management. But the main source of water is groundwater. There's a couple of aquifers, a shallow one and a deep one. But there's sort of lots of unregulated wells have been added to the oasis recently, and this has meant that the groundwater has become scarce and also salinized, which is a threat to the original oasis here. You can see some Foghorahs. I've tried to mark them out in pink, but they're perhaps not very visible. But as well as these water quality issues in general, the oasis suffers from desertification and flash flooding. Some issues around sort of inheritance of land and water rights, the existence of sort of almost competing water management strategies. Some anti-desertification measures are being taken, such as tree planting and so on. So I talk about this one because it's a newly proposed globally important agricultural heritage system, and it's been relatively well researched recently in the framework of sustainable water use and also heritage by NGOs and academic projects, several universities, for example. Some of the criteria for its irrigation are things like sort of knowledge about that irrigation and water allocation law, and a sort of rich agro-biodiversity there and knowledge of water management. And you can see here some of the abandoned areas of irrigation, abandoned foggerers, and now dry field systems. Originally there were sort of 7 villages here in the traditional oasis, with water irrigation sort of organised by each of those villages, each managing its own sort of source, its own network, sort of a network of mainly stemming from these foggerer systems. But I think a new water users community has now more recently been established. But water resources are very scarce here. And you can see we've now got this spread of new cultivation surrounding the original oasis. And as I say, things like wastewater management, tree planting, capacity building, things are being done to try and combat desertification here. So one of the other things I've been doing is mapping the locations of foggerers in southern Morocco, trying to get an idea of their distribution, and trying to get an idea of how many of the sort of oases in this area have a foggerer or 2 or more. Of course, there was activity in the area before the medieval period, but not much is known about the earlier stages of irrigation. A lot of it is sort of underneath some of the modern oases. You can see here many dense clusters of foggerers in areas where groundwater is available. These are in oases and between the mountains. There's also some runoff water sometimes in some of them as well. And there does seem to be quite a sort of limit to their range on the southern edge of the Sahara. This is actually the southern bit of the Dra Valley, which sort of goes down here, although it's generally dry. Some of the modern oases, or many of them, have at least a few abandoned foggerers. And perhaps these foggerers enabled the initial creation of these cultivated environments. As well as sources of groundwater, there are many wadis in southern Morocco, and with seasonal runoff water. And many of these oases, foggerer oases, may have originated in the medieval period. But more research needs to be done to date them and contextualise them. We know this was an important area in the medieval period. Hopefully I'll manage to get to the end of this before my voice gives out. You can see a nice example from the satellite imagery of some foggerers in this area here. So looking at the time series of vegetation and rainfall data, in most cases it looks like these foggerers have been abandoned, these little foggerer oases, at some point in the past. We're not sure how many of them are still active. We can understand when things might have changed and why, how they might have been impacted by recent issues such as climate change and pressures on resources. So sometimes we can see that the oasis areas move slightly away from old foggerer-fed cultivation to new fields using pumping. So in this example, you've got a few foggerers here, areas of traditional oasis, most of it dry, with just a little bit there, probably also now using pumps. But at some point around 2000, which we can see in the time series of vegetation indices, that it moved over here, cultivation and some new pumps, and the foggerers now look disused. So the problem for many of these oases isn't just that an oasis has been abandoned, at least in the last 40 years, but the cultivation has changed, new areas have been established nearby using pumping, which can actually lower the groundwater to the point where the foggerers become unusable. So I'll finish up by talking about the Dra, which I've been collaborating on with the Middle Dra project. This is a particularly productive oasis in the Sahara, both today and in the medieval period and possibly earlier, because it's got a nice perennial river, which is quite rare in the Sahara. This is fed from the Atlas, but now controlled since the 70s by a dam at Oasis. And so generally the river doesn't flow beyond the town of Mohammed, but as we can see in 2014 it did, which is quite rare. So generally this bit of the Dra is not cultivated because, and there's not much trace at all of kind of medieval activity alongside the Dra here. And we know there have been other historical floods occasionally when this happened, but it is far from the norm. It's an unusual event. So you can see this chain of oases here, where MDP is working in the Middle Dra, and you can see they sort of stop around here, around Mohammed. There's not many foggerers here. Most of the irrigation are canal systems, earthen canals associated with villages, a nice network of canals inside this beautiful oasis. So this could be a water management landscape, perhaps established in the medieval period or the post-medieval period, which is still operating on those same lines. And indeed, any traces of sort of earlier irrigation are sort of hidden under that, those sort of medieval and post-medieval oasis landscapes. There's loads of cool archaeology here, which I don't have time to talk about today. We know this was an important area in the medieval period. It did function as a trade route, if not as, maybe not as important as the Tafilet. There was an Almoravid fortress here in Zagara, where MDP has been researching. So because these oases are cultivated, it's very difficult to research them archaeologically to try and find what sort of earliest phases of them are. But there's a nice area of abandoned oasis in the south near Mohammed in the Casabunno area, which gives a really unique opportunity to study the layout of the canal system in detail and to investigate what might have made the area, this area of oasis ultimately unsustainable. So as you can see here, we managed to identify the head of the canal system up here, and very visible as a main canal, and many laterals stem from this. Probably extracting from the Dra somewhere around here. So from our excavation of the main and some of the laterals, we can begin to estimate the discharge of the system. And it's also easily mappable for satellite imagery, so the extent of the oasis can be recorded. Based on radiocarbon dates from associated structures and field walls, it's possible that there were several phases of irrigation with the cultivated area and canal network being extended. However, this activity sort of started to tail off perhaps after the 17th century, and it's possible the cause of this was environmental. The Dra is significantly below the level of the fields here. So you can see I was in a sandstorm walking along the edge of the Dra here, which is quite far below the level of this canal we're walking along. So it's possible a flooding event caused the river to be downcut and made the irrigation system just unviable. And you can see from the corona image here, this is also obviously long abandoned by the 60s. You can even see the sand dunes. But you can see the sort of the currently active areas of Oasis at the time down here. So it's possible that the sort of canal system moved to the other side of the river, the Oasis moved. It could have been a replacement for that medieval system. So in a way, that's also a form of adaptation to sort of environmental challenges. Just move the Oasis if the old one becomes unsustainable. You don't have to move it that far. We spotted some water lifting devices along here as well. However, flooding obviously has a big effect on irrigation systems, not just now, but also not just in the past, but also now. So this flood in 2014 was captured by Landsat 8. And you can see the Dra full of water here. And here's an example of some of the damage to the irrigation infrastructure we observed. This was caused by the floods, and it was still visible in 2016. And areas of the Oasis were dying as a result of this. Now, a large gravity flow reticulated system, sometimes partially state-controlled, can be very vulnerable to catastrophic events like this, both in the past and today. It can take quite a while for complex systems to be repaired after an event like this. Yet the frequency of flash floods is expected to increase due to climate change. And this is just an example of some anti-desertification defences. So it's important to look at an area of abandoned oasis like this, very dry, eroding, invaded by sand dunes. Looks quite a desolate sort of landscape. You wouldn't look at this and think oasis. It's important to see this and realise, and remember that it once looked like this. This amazing lush oasis was this sort of earth and canal system here. So just to finish off before my voice completely gives out, so I'm at the start of this fellowship, but I'm thinking about the next steps for the research. When we view these landscapes from a long-term perspective, not just as scattered snapshots from our period of interest, we can start to build up a long-term picture and to what extent they were resilient. I'm hoping that fieldwork will become possible again because a more detailed understanding of chronology is needed to try and understand the sort of challenges they dealt with over a long period. And I think in archaeology, we can stand to move discussion of water management well away from sort of Wick, Vogel, water and power, those sort of narratives, and much more towards resilience and sort of addressing future challenges. And in geography-related subjects, we need to sort of stop ignoring the long-term evidence offered by archaeology and history in order to avoid making the same mistakes of water management strategies. An important next step is considering how our knowledge of past water management could be connected to modern water policy. And to do this, I think we could do worse than to leverage the globally important agricultural heritage system framework and its process of designation. I think some of these case studies I've discussed today would be good contenders for designation. So thank you very much. Thank you to my funders and also to all my collaborators. We've got some papers on this subject if you're interested in reading more. Most of these are open access. I just want to finish by adding I'll soon be advertising to recruit a PhD student to come and work with me at Newcastle on this project. So if anyone wants to get in touch with me about that, please do. I'd be very happy to discuss it. Thank you very much.
Well, thank you very much, Louise, for the presentation, which shows the importance, the relevance of your work, as well as the complexity of it, and how wide-ranging this is. And I think it is particularly fascinating that we emphasize the importance of the past also for the future sustainability of these water systems. So I think that is really a very crucial aspect of your research. So now we've got some time for questions, and just a reminder for those who may have joined us a bit late, if you have a question, please use the Q&A feature, which should be at the bottom of your screen. You can type your question and then Louise will answer your question. Okay, I can see that we've got a few already. The first one comes from Isabel Miller. She says, of course, we are in an entirely new situation with climate change. However, in terms of how to use water sustainability, have you examined the material in old WAPS, I believe the pronunciation is not quite right, documents where there can be detailed prescriptions of water use? Also, what links are there between these studies and any work on the irrigation in Iran? Because there was a lot of work in the 60s, 70s, and 80s on both historical and geographical subjects related to water use.
Yeah, thanks very much. There's definitely more work to be done in terms of looking at some of the archives and historical documents. So that's the sort of direction I'd like to take this research, if I can expand it a bit. In terms of Iran, I mean, of course, it's a really interesting area for looking at kanats or fogras or whatever we want to call them. And it's been quite interesting that there's been some really nice detailed attempts to document these, including quite recently, interviewing sort of kanat digging professionals and really understanding also how water was allocated and actually highlighting how dangerous a job it was to be a sort of kanat digger and kanat maintainer. So, and I think some of these ones have been looked at in terms, sort of with a view to some extent to sort of restoring some of them. Many of these ones in North Africa, that's not so possible because the water table is now is not at a level where these could easily be generally reused. But yeah, Iran makes a sort of interesting comparison, slightly outside the scope of this study, but really interesting, especially for kanats.
Yep. Next question from John Mason. Can you kindly address the issue of water delivery sustainability in Libya's interior oases? Traditionally, water was obtained from hand-dug wells, drawing from subterranean sources. More recently, during the previous regime, water has been piped from distant aquifers. How sustainable are these sources? In the latter case, I'm referring in particular to the Augila oasis.
Yeah, I mean, not incredibly sustainable. So these are not particularly recharging. And with climate change, it's not just climate change, but also an increased pressure on these resources. So more and more extraction of these resources, they get harder to reach. And possibly it's sort of a comparison with the sort of earlier periods, the water table just became too difficult and too expensive to reach. Perhaps the same thing can happen now if these are relied on. But with other sources of water, perhaps in areas where there can be some runoff gathered from rainfall, if that becomes more uncertain, more unpredictable, we begin to rely more and more on the groundwater sources. So it's likely to become much more of a problem in the future.
Next question from Timothy Norris. To what extent can concentrated solar power systems be used to desalinate water from underground aquifers to provide irrigation water?
Yeah, I think this is being explored in some places. The problem is it's very, very expensive. So to kind of make it sustainable, it also needs to be affordable. I think in some of the locations in Morocco, people are sort of considering mostly things like how can the sort of current systems just be made a bit more efficient, but also things like trying to clean up wastewater and use that for irrigating palms. So not using that for domestic water, but using it for palm irrigation. So trying to find ways that aren't very, very expensive to just increase water resources by being more efficient. Yeah.
question from Robert Foley. Are there estimates of the time, budget, and the workforce requirements for building and maintaining these water management structures? And do the costs vary much between types and periods?
Yeah, so this is an interesting question, and of course it varies very much between the different regions. So there is some literature for some historical texts, for example, for Iraq on this. I'm trying to remember all the details, but the sort of type of labour that could be called on to do this work. I think sometimes in the medieval period, it was even using slave labour, so-called sort of Zanj thing with a slave rebellion, to get them to sort of scrape the salt out of the salinised fields into sort of ridges and things. We know for Kanats, again, from those sort of examples in Iran, there's more recent examples that have been so well documented, that there were sort of Kanat digging specialists. So I should think it's quite possible that these kind of specialists existed in other areas where there were Kanats, and they knew how to how to find the location where the groundwater was likely to be high to sort of put the mother well, the first well in. And it sounds like it was quite a dangerous job. They were quite often dying or getting injured from working in these tunnels, but there were definitely specialists involved who could be hired. And I think they probably moved around a bit in the areas where there were where the Kanaks were present. So it's possible, if we look into it, we could find that evidence of something similar in North Africa as well.
I see. We have another question from Timothy Norris. Can you comment on over-extraction of water leading to decline of various settlements, like, for instance, Gadames?
I maybe can't comment on that one in particular, but it definitely could have been a cause of decline, this sort of over-abstraction. So some of these areas in Jufra, for example, we can see that there's these areas of settlements and things that are very closely associated with the Fogras there. And that the whole thing seems to have been abandoned. In fact, no real activity there at all, which is partly how we're able to record it until the present day, when the Oasis is now expanding again. So it's possible that, I mean, I guess it could be one or the other. It could be that for some reason the settlements are abandoned and therefore the irrigation system wasn't maintained, so it was also abandoned. But it could be over abstraction. I mean, we know this is not sort of a non-replenishing resource, the groundwater there. So it's quite possible that abstraction reached a point with so many Fogras that it became unsustainable and too expensive to reach groundwater anymore.
Yeah, actually, I think I have a question myself. It may not even be related, so please correct me if I'm just talking nonsense. But among the many methodologies that you're applying to your projects, and we've seen how complex these are, I was wondering if, I don't know, perhaps for the smaller water management systems, you are also planning to do a sort of ethnological, anthropological approach by talking to people who manage these water systems, having interviews with them, whenever fieldwork will be possible, again, we hope soon. So if you think this is also something that you could do as part of your research. Yeah,
that's a really good question, because this is something that I'd really like to do. Obviously, in the course of the fieldwork we've done so far, we've spoken a bit with a few people sort of anecdotally in the area, but it would be nice to make this into a sort of formal, perhaps ethnographic kind of process. So if I know that Lamin's spoken to some of the farmers in Jufra, and I think some remembered, or they said their father or grandfather remembered a couple of those Fogras near Hun being in use. So that could be a sort of a later phase of irrigation to the cluster of Fogras south of Verdun. And I think for the one or two Fogras we found in the Dra, we managed to speak to someone who was working nearby who said something similar, that he or his father perhaps remembered that Fogra being in use. Obviously, these ones in Iraq seem to be a lot older. These are sort of some of the earliest phases of irrigation. But we found ways of kind of understanding the configuration of linear features in the landscape there by talking to people. So Jaafar and his students were speaking to some farmers there who initially sort of wanted to question why they were there, but became more chatty when they spoke to them. And they were mentioning how when it used to be sort of marshes there, they were driving their buffalo through the reeds, and these created sort of channels in the reeds, so sort of canals through the reeds. So some of the linear features, and Jaafar's been doing a lot of mapping of those in the area. We can kind of understand how those are created after speaking to people in the area. So yeah.
Okay, yeah, sounds great. Now we've got a question from Jaafar Jotheri. who says, thank you very much for this great talk. And he has a comment. I hope that IAMINA will have a plan to document the ancient water management system and not only the archaeological sites.
Yeah, so I'm not in particular working for IAMINA anymore, but of course still collaborating. So these can go into the IAMINA database of water management sites, trying to get, we can obviously document linear features, not just points. So quite a few of the FOGRAs, especially the Jufra ones, are already in that database. But at some point, I'll send people a load more FOGRAs, and it'll just be FOGRA. But yeah.
Okay. Then we have a question from David Mattingly. Great talk and really interesting to see how your project is developing. The results are really impressive, and especially for the FOGRA and canal systems. Have you any plans to look at artesian spring-fed oases as well? And it's thinking in particular of places such as the Jerid and Naftaoua in southern Tunisia.
Yeah, definitely. That's a sort of another phase of things that I want to look at. Many of these features are visible, so can be mapped. And in particular, Tunisia has been sort of particularly highlighted by some of the sort of impacts of climate change research. Those oases are particularly at risk of salinisation. So it would be nice to try and map these soon if possible.
Yeah. Question from Graham Barker about what is your strategy for trying to sort out the chronology? In particular, how feasible you think OSL dating and radiocarbon dating and other forms of dating could be for these structures?
Yeah, I mean, that's a good question, because it's quite a big sort of problem and a big topic in sort of water management, water history research. Just so many of these past systems are just not dated. Of course, it's quite hard to find. Sometimes it's hard to find data material in these features, as people know who I've dragged along with me to dig holes in FOGRAs and canals looking for something. But I'd like to rectify that a bit with this project where I can. So for the case studies at the Iraq one, we've gathered radiocarbon dates. We managed to find shells. For some of the others, they're reasonably well dated just by association with the only other features that are, with the field walls that are associated with them. For example, the ones with the MDP project, and there's quite a few radiocarbon dates for some of those features there. I'd like to do some OSL dating. That would be good. Obviously, getting the tubes back to the UK to be processed in the lab is quite difficult, because you need someone to not open the tubes when going through airports and things. So after Newcastle Airport opened up our radiocarbon samples, which luckily just about survived, but I'm not sure what they would have done with some nice tubes of sediments. But it's something that it would be nice to do in future field seasons, and I have got a budget for doing some OSL, so that's definitely in my plans if we can ever return to do field work.
Good. And we've got a final question from Chris Hunt. Have you any information about the social organization underlying your systems? In some long-lived European systems, such as Malta, Switzerland, and Spain, there is a sort of cooperative organization. So do you see anything like this? And how do you demonstrate sustainability? Yeah,
good questions. And again, this would be something that would be nice to address through slightly more ethnographic research. So some of the ones in Morocco, for example, we know that each FOGRA or canal has its village, and that village has sort of controls the water allocation there. It'd be interesting to get into the detail of exactly how that's allocated, so who gets most water. And there are some examples that are quite well known in the Middle East and North Africa, for example, some kind of Arabia, where we know how, sort of, for example, people were allocated amounts of water based on time. You've got your 40 minutes of water a day or something. So it'd be nice to look into that in some more detail in some of these case studies. Yeah, and it, sort of in terms of sustainability, that's one of the things I'm sort of hoping to assess. How can we demonstrate were they sustainable or not? I think some of it does come down to longevity. If you have an irrigation system or a water management system in an environment that seems to have lasted on more or less the same lines for many years, for a long period of time. And for example, some of these ones in Morocco, and perhaps some of these ones in Iraq, although now desertified, may have existed for quite a long time. And this suggests these approaches were quite sustainable. The problem is even if we were to somehow renew or preserve these approaches, these systems, can they still be sustainable kind of in the face of climate change, or does it start to become a bit impossible? That's a question to sort of look into, really.
Sure. Okay, well, I think that was the last of our questions. So again, I would like to thank you, Louise, for this great talk and for sharing all this information with us. And we're really looking forward to seeing the next steps and the following results of your work. So really good luck with it.
Thanks for inviting me.
And just before we all disconnect, I'd like to remind about our next lecture, which will be the last lecture before the summer break, which will be by Chris Hunt on the Little Ice Age in the Southeast Mediterranean and Southern Southwest Asia, which will be on the 8th of June at 5 o'clock UK time. So please join us for that one as well. Again, thank you very much, Louise. Thank you, everybody, for joining us tonight. And, well, have a good evening.
Now I'm going to close the meeting. Good night, everybody.